Welcome to clickmyproject.com. Now we're going to explain systematic structural testing of firewall policies. It's under the domain of network. A firewall can either be software based or hardware based and is used to help keep a network secure. Its primary objective is to control the incoming and outgoing network traffic by analyzing the data packets and determining whether it should be allowed through or not. It's based on a predetermined rule set. A network firewall builds a bridge between an internal network that is assumed to be secure and trusted, and another network used in an external network such as the internet that is not assumed to be secure and trusted. Many personal computer operating systems include software-based firewalls to protect against threats from the public internet. Now I'm going to explain abstract of the paper. Firewalls are mainstream for protecting private networks. Firewall quality is directly ensured by the firewall policies and are difficult to overcome this difficulty to propose systematic structural testing approach for firewall policies. Firewall policy tests undergone through 3 structural coverage criteria based on rules, prediction, and class. To achieve high structural coverage effectively, to have developed 4 automated packet generation technique. First one, the random packet generation. Second one based on local constraint solving. Third one based on global constraint solving. Fourth one based on boundary values. We have conducted tests on set of real policies and set of faulty policies to detect fault with generated packet sets. Structural coverage has higher fault detection capability. Our result shows the reduced packet set maintains similar fault detection capability. As an enhancement work, policy verification process has been included in our proposed system. Now I am going to explain brief concept of the paper. To defend against malicious attacks and unauthorized traffic, firewalls are crucial elements in securing the private networks of most businesses, institutions, and home networks. A firewall is typically placed at the point of entry between a private network and the outside internet, such that all network traffic has to pass through it. In a distributed system, messages are encapsulated into packets, which often passes through multiple access points in a network, and firewalls are responsible for filtering, monitoring, and securing such packets. To propose a firewall policy testing based on the concept of firewall policy coverage, which helps test a firewall policy structural entities to check whether each entity is specified correctly. In firewall policy testing, test input and output are packets and their evaluated decisions respectively. A firewall, whether a physical device or software based is an effective tool in our security store for controlling both inbound and outbound traffic on your computer. Firewalls can be physical devices which circuits dedicated to monitoring TCP/IP transmission, such as routers and gateway. Software programs that run in the background as operating system services or hybrids that incorporate rules-based software in connection with a physical firewall device. Regardingly of the firewall type, to develop a firewall policy test ensures your computer security integrity. Firewall policies are constructed based on some constraints, that is source IP, source port, destination IP, destination port, and protocol. We are framing the rules by defining some conditions. After the generalization of rules, firewall policies are tested under structural coverage. If it satisfies the rule, packet will be accepted, otherwise discarded. Now I am going to explain data flow diagram. First of all, we are generating original packets by using Colosoft packet generation tool. After packet generation, firewall policies are constructed based on system resources. Firewall policies are undergone through structural coverage criteria. There are 3 types of criteria. Rules coverage based on source IP and destination IP and conditions. Predict coverage is determined based on packet sets. Class coverage is evaluated at least once, either true or false based on predictions. Actually, constructor packets are verified once and generates access control list. If it is true, it will reconstruct the policy rules. Before testing the packets, we have generated packets using 4 types. It will produce some set of packets. Test packets are then evaluated. Test packet reductions is done using greedy algorithm. Finally, we will get reduced packet sets. By using these packets, we define the faults by checking the actual decision and expected decisions. Faults are detected removed based on the policies. Finally, we will get the original packet sets without any faults. Now I am going to explain demo of our project. First, start WAMP server because data are retrieved from databases. To open Addons to run home.java. To click generate policy. In that form, to choose generate policy, the policies are generated. And click test policy. In that form, to click firewall rules, the rules are generated and the rules are displayed. Click structural coverage. In that form, to click rule coverage, the percentage of the number of covered rule in a policy is to be estimated. To click predict coverage, here the percentage of the number of covered predicates is to be estimated. Click class coverage. Then percentage of the number of covered true or false values of classes are estimated. And click policy verification. To click rule verification, if the rules are satisfied, it will display them. It means it will check whether the packet should be accepted or discarded based on decision in firewall policy. By defining the predicates for number of packets, it will produce the matching rule. The same is applied in class coverage based on Boolean values to check whether the packets are original. To avoid packet loss, we are reconstructing the rules. We fix the access control list. After construction of control list, we are testing packets with the decisions. Click test packet and the test packets are generated and there will be these packets are displayed. Click evaluation. And the test packets are evaluated based on the decision. And we have removed the null decision packets. Click test reductions. Click greedy algorithm and the packet reduction is constructed based on greedy algorithm. After reduction of test packets, we use to detect fault packets. So the test reduction is completed. So null packets are removed. Click fault detection. The next form is open. So the final value of actual decision results are displayed and the expected detection values are displayed and fault detection results are to be displayed. Conclusion is, we have developed a systematic structural testing approach for firewall policies. We define 3 types of structural coverage for firewall policies. First one is rule, second one is predicate, and third one class coverage criterion. Among the 4 proposed packet generation techniques, the global constraint solving technique often generates packet sets to achieve a highest structural coverage. Thanks for listening.